Welcome to the Explainer. Today, we are jumping right into a truly epic chronological journey. We're going to look at how we went from just, watching shadows on the ground to splitting time with sub-nanosecond precision. It's the fascinating story of the march of time and how humanity gradually learned to measure and control the clock. So, how did we actually do it? Well, for our earliest ancestors, there were no strict schedules. Life was entirely what we call task-oriented. They worked when the sun was up, right? Their entire lives were dictated by the vivid natural scenes unfolding around them. The changing seasons, the sunrise, the shifting tides. Time was just nature, and they lived in complete sync with it. Section 1. Sun, shadows, and water. Just picture this scene. Ancient Egypt, around 1500 BCE. Priests are out there using these huge stone sundials. They'd point a triangular piece right at the North Star to cast a shadow, literally carving the daylight into measurable chunks. Then, flash forward to the 3rd century BCE in Greece, and we start seeing steady water clocks popping up. Fast forward again to the 14th century, and boom, hourglasses become absolutely essential, especially out on the open ocean, where a rolling ship doesn't mess with the steady downward flow of sand. Now, sundials were a brilliant start, for sure, but they had one massive, fatal flaw. They were completely useless at night or if you had heavy cloud cover. Well, water clocks, also known as clepsydras, they ingeniously solved that problem. From ancient China all the way to Greece, these devices measured the regular, constant flow of liquid. You could actually read the time in the pitch dark. And then, this Greek engineer named Chrysippus of Alexandria takes a huge leap forward. He adds gear wheels and a dial indicator to these water clocks. This was our very first taste of mechanization and time measurement. Okay, moving on to Section 2. Early mechanical marvels, the soul of the machine. During the Islamic Golden Age, mechanical engineering just exploded. Imagine standing in front of Al-Jazari's towering elephant water clock. It was this incredible masterpiece with moving figures, dragons, and complex internal waterworks driving all these gears. Over time, this brilliant Islamic engineering transferred over to the West. And that fertile ground of innovation, it set the stage for one of the most important inventions in horological history, around the year 1300, the Verge escapement. I cannot overstate this. The Verge escapement was a total game changer. This one singular mechanism made the very first fully mechanical clocks possible in 1300s Europe. It allowed for oscillating timekeepers, balance wheels, that actually ticked and talked. And that led to the rise of those massive iron-forged mechanical clock towers that soon dominated medieval European cityscapes. We were no longer relying on water or the sun. Pure, unadulterated mechanics had officially taken over. And this mechanical breakthrough? It completely rewired human society. Remember how we used to live with that natural task orientation, governed organically by the seasons and the sun? Well, the mechanical clock, and later the Industrial Revolution, forcefully shoved us into clock time. Suddenly, life shifted to rigid, unnatural 9-to-5 schedules and strict industrial discipline. Time literally transformed into a commodity. It became something you could spend, save, or waste. But here's the cool part. These mechanical marvels became a lot more than just cold instruments of industrial discipline. The rhythmic beating of a balance wheel actually feels alive. To quote one modern watchmaker, a mechanical watch has a soul. It has a heart. It has life. It has something breathing inside of it. Watchmaking evolved into this profound art form, a living organism of craftsmanship that beautifully bridged our historical traditions with future technologies. Section 3. Pendulums and sea navigation, perfecting the beat. So legend has it that a young Galileo was sitting in a cathedral totally mesmerized by a swinging bronze chandelier. He realized that its steady, rhythmic swinging could perfectly measure time. Inspired by that natural pendulum rhythm, a Dutch scientist named Christian Huygens actually engineered the first working pendulum clock in 1656. And wow, did that provide a massive, unprecedented leap in accuracy, as long as the clock stayed on solid ground. But what happens when you're not on solid ground? Pendulums are fantastic in a static, quiet room, but they are utterly useless on the violent, rolling, unpredictable deck of a ship at sea. And to navigate accurately, especially to figure out longitude across vast, featureless oceans, sailors desperately needed precise time. It was literally a life-or-death situation. This urgent need drove pioneers like John Harrison to create the marine chronometer, a highly accurate, portable mechanical clock that fundamentally changed global sea navigation and international trade forever. Section 4. Standardizing the world's time, the age of the railroad. Why did we suddenly need a universal time? Well, picture the terrifying speed and heavy iron of the new steam locomotives. As railroads expanded rapidly across continents, every single local town still kept its own local sun time. That meant two trains could easily be barreling down the exact same track, operating on completely different schedules. The resulting chaos inevitably led to deadly, tragic train crashes. The railroads basically put their foot down and demanded that everyone coordinate their clocks to a single standardized schedule to keep people safe and the trains running on time. To fix this, in 1884, representatives from countries all over the world gathered at a massive international summit. They agreed to adopt Greenwich Mean Time, or GMT, as the world's universal time standard. The prime meridian, which represents 0 degrees longitude, runs directly through the Royal Observatory at Greenwich. That made it the official starting point for both time and distance on our planet. Finally, our global clocks were synchronized. Which brings us to Section 5. The era of atomic precision, sub-nanosecond accuracy. If we just look at the last century, timekeeping technology evolved at an absolutely blistering pace. It started with the quartz crisis in the 1970s and 80s, where these cheap, highly accurate quartz crystals devastated the traditional mechanical watch industry. But they gave everyday consumers a massive leap in accuracy. But for science, metrology, and deep space navigation, we went much, much further. We developed incredibly complex atomic clocks, beam clocks, fountain clocks, and optical clocks. Today, modern technologies like GNSS discipline oscillators measure time with mind-blowing sub-nanosecond precision. I mean, we are quite literally splitting nanoseconds here. We have journeyed all the way from tracking shadows on ancient sun-baked stone in Egypt to measuring the invisible, high-frequency vibrations of atoms in modern laboratories. We've mastered measuring time with unbelievable precision, but do we truly control it? Or does the clock ultimately control us? That's a profound thought to end on, right? It perfectly summarizes our incredible historical journey. I really hope this explainer has given you a newfound appreciation for that ticking watch on your wrist. Thanks so much for watching.